Hello and namaste and welcome to one of the most important session in coding is conditional statements. In industry, generally wherever there is a business logic, it is said that close to 35 to 40% of the code is related to, you know, conditional statements, which includes the logic, or that business logic is what we call. And a lot of bugs and issues also come in this part of the code. And all it takes for a developer to make a very small mistake from less than to greater than, or not equal to equal to. So very small, or say something like an and replaced by an or, right? In terms of typing, those mistakes are just one keystroke. But the impact of that can run into millions of dollars. So I will tell you two interesting incidents where the losses were very huge. The first one is by one of the very biggest multinational retail company, where they had to give a discount for products which are less than $100. The discounts had to be given only if the product value is less than $100. But they ended up, the developer unintentionally, instead of writing less than, wrote greater than $100. And the discounts were applied on all the expensive products on that retail website. So what happened is this bug went undiscovered for many days, but the customers discovered this. They didn't discover it as a bug and they thought suddenly, oh, maybe this company has become too generous and they're giving these huge discounts on expensive products. And they all ended up buying millions of dollars of worth these goods. And this company had a huge loss. Now they cannot claim back that money because it was given on their website and proper invoice was raised. The discount was legitimate. There was another example by another retail store where the earlier, if you to give the number of quantities you need, let's say you have a price and then you multiply that by quantity, right? Now generally in most of the businesses now, retail businesses, this quantity field is generally a drop down box, so where you have quantity now that you can select. But earlier this used to be a text box where you can type the quantity. And some curious person thought, let me see what will happen if I type -1. So what happened? Let's say the price was $10, minus multiplied by -1, this became -10. And the business logic, whenever in computation, if there is a negative value, they had a process thinking that maybe it's a refund or we owe money to that customer, and they would refund this money and credit this money to that buyer's account. And this person revealed this to few friends and then it got spread to other people, and again company lost millions of dollars for this, because when this quantity was entered as -1, there could have been additional check saying if quantity is greater than 0, then only do the processing, otherwise you respond saying it's an invalid quantity. It should have checked if it is greater than 0 and it is less than some max value. That, see, they cannot ship hundreds of things, right? They'll say max than 10 or whatever. So this condition was missed. And then there is a third and the last story I want to tell you, where one of the famous space agency, they had fired a rocket. And generally, what happens is when you build a rockets, it is not like a single organization and single department that builds it. They collaborate with hundreds of suppliers, vendors, partners, other countries, friendly countries, to build a rocket. And there was a system integration. There were two systems, and both the systems were supposed to talk to each other. Of course, they were done in two different countries. So the units or the metrics they used for measuring certain parameter, they both were different. They both were different, and in the rockets there is no second chance. You fire it once, either it will land where it has to go, or it will land in the ocean. So there is no second chance. And because there was no condition that was checking this, the rocket, instead of going to space, went it to bottom of the ocean. So as a developer or as a programmer, when you join the industry, I think you will encounter bugs that was done, they were done by others that you may be fixing, or your own bugs will come from your own code. So whenever you are writing these conditional statements, make sure that you pay that extra attention. Otherwise, you never know that your bug can become a story in someone else's class in future. With that background, let's get started. So in case of conditional statements, be it any language, Python, C, Java. So basically you have if and you have a condition. And if this condition is true, then it executes this block. It could be as simple as this, and else is not compulsory. You could write it very much like this. If this condition is satisfied, then you execute this lines of code. Otherwise, if there is other lines of code, let's say below this, right? So what will happen? The program counter or CPU will jump to this line and it will continue. And if there are no lines, if this is end of the program, it is end of the program. So this is one part. Now, what is the second part? The second part could be you have if and you have a condition, and if it is satisfied, if you meet this condition, it would run this block, and else there is another block that it would run. Block in the sense it could be single line of code or multiple lines of code. So this could be the other pattern. Then the third pattern is else if. So else if is generally used this way. So you have if followed with the condition, and then you have a block, then you have else if, then again a condition, then a block, then else if, then a condition, and then a block, and then finally else. So this is where there are multiple conditions. One of the example you can think for this is, let's say based on student CGPA or percentage, you want to tell whether it's a distinction or not, right? So there could be a condition here for distinction, for first class, for second class, and then for fail. Many times when you write business logic, you would have this. Then what could be the other patterns? The other pattern could be this way. So you have a condition, and within this again there are sub conditions. So you have this, then you have this. So it could be nested this way. And the same thing can be written in different ways, and always developers have these debates in company saying, oh, probably if you take this out, the code will look simpler and easy to understand. So people in the industry, they'll have debate saying, oh, this if condition you should merge with this, maybe you should invert this to this. They will say, and that whole debate is all about how to make it less buggy, less error prone, and how to make it easy to understand. Right? So other patterns could be a nested if like this. Now, what are the operators that we use? So in our previous videos, you saw all mathematic or arithmetic operators. So now for the conditional statements, one of the important operators that you use are called logical operators. So these logical operators, basically you have something like, greater than, then less than, or equal to, or not equal to, then greater than or equal to, then less than or equal to. So all of these are the logical operators. And many places, the combination of if-else, conditional operators with this is what conditional statements with logical operators is what helps to write a business logic. So let's say you are making a hiring decision in a college, right? So the student has CGPA. Then you have the students CS skills, computer science skills. This is rated between 0 to 5. The CGPA is 1 to 10, and this is a floating point number. Then you have the student communication skill rated 0 to 5. Then coding skill 0 to 5. So various skills, when the interviewers assess that candidate or student, across the skills they give them some rating, and that rating get entered in an Excel sheet. And then finally, they look at the numbers and then they say, okay, this is our hiring decisions, right? So they'll say, okay, if we have to hire, the CGPA has to be greater than 7. The coding has to be greater than 4. The problem solving has to be greater than 4, right? Communication has to be greater than 4. CS fundamentals have to be greater than 4. So bunch of these parameters will decide whether that decision will be made. Like this, you will encounter these logical statements everywhere at so many places. And I will give some real life examples from your current thing. Like say, if you go and try buying anything on any of the apps, the retail apps or shopping apps or food delivery apps, you cannot place the order for -1. And this is where I would like to all of you try this example. And I know that we all have these, in India especially, we all have these UPI apps, okay? So go there and open a UPI app, and for your friend, try to transfer -1 rupee, okay? Open that app, go to that app and go to your friend's number, okay? I'm just trying to open my wife's phone number and enter -10 in the app, one of the app, UPI app. And I'm trying to see what happens if I try to send it. Thank God that they have put a conditional statement and a check. I was hoping whether I'll get back 10 rupees from her, but it doesn't. It is handling it. So it is basically what it did is it realized that it's a negative number and it sent that -10 as a message to my wife. Okay. So now let me put an extremely large number. Okay. I put a number like 10 lakh rupees. The moment I made 10 lakh rupees, it is again sending that as a text message to her and not actual money. After 1 lakh, automatically it changes to text from the money. But if I put a proper value, which is between 1 to 100,000 or 1 lakh, I am able to send the money. So in lot of the places, be it space technology, rockets, missiles, or financial transactions, everywhere these conditional statements are heart of the software. They are at the core of the software. And in the interviews, we see candidates make mistakes with this, which we are okay. And when we give them a test case or an input, we check whether the candidate can find the mistake, that logical mistake they have done, A. B, will they fix it properly, or in hurry-burry or in tension, they fix it in a way that it creates another problem. And if somebody does the second thing, then they generally get rejected. Generally, all other goodness or other things will not be sufficient. So it's okay to make mistakes, but when that get pointed out, they need to be careful and fix it correctly, because you develop these kind of critical things where if you allow a negative number, then somebody probably end up losing their money, right? Or company end up losing their money. So these are interesting examples. Now there is not much to explain with respect to this less than, greater than, these symbols. These are pretty much mathematical, but one of the important symbol that we all use is something called equals to. Like say, if I want to check if somebody's age is equals to 18, then they are and eligible for some special benefit. So to check if that is equal to, you use this 2 equals to symbol. In modern programming languages like Python and Java, if you write only age equals to 18 in a conditional statement, you get interpreter errors or compiler errors. But in C program, in C language, this doesn't exist. So what happens in C language is very tragic, very severe. In C language, if you say age, if age is equal to, instead of double equal to, you write single equal to, the value 18 get copied to this variable age. And since it is a positive value, the if condition becomes true. The if condition becomes true. And this causes severe issues and bugs. And I have seen this kind of bugs so many in my career early on when I used to write code in C. So be careful about this double equal to symbol. The next one is, now you can have more nested conditions. The nested condition is like, you will say this is your condition 1 and condition 2. So in Python, you can literally write and in other languages, they write this and you write here condition 2. So this is an and operator, where conditional operator, where this will be true only when these both are true. Both are true. Which means this if block will get executed only when these both conditions are true. Then only the below block get executed. And if one of them is false, either this or this, then it won't execute. So this is the and condition. And similarly, now you have or condition, where if any one of them is true also, the code would get executed. So condition 1, and you have or, and then you have say condition 2. So if any one of this is true, right? If any one of this is true, then the code would get executed. So in real life, when you are developing software, there are many places where you need to write code this way. Now that UPI example, how they would have written the condition, they will write it like this: if that amount is greater than 0, and if other language, they would write like this. In Python, you can write and, right? And then they will say amount less than or equal to 100,000. So this is how they would have written the code. Now they don't want to allow you to transfer 0.01 rupees and all, right? So for that, what they would do, they will not say greater than 0. They may say, instead of this, they may say this way. They may say greater than or equal to 1, right? Like that, what we have done there. So it will allow anything between 1 to 100,000 inclusive of these two values. This is how they would have written the check in that application and in that UPI application. And if the check satisfies, then it will allow the logic to transfer the money. Otherwise, it is converting this value to a simple text message and allowing the person to send it. Okay. So this is how a real life conditional implementation would look like. And then there is this thing called, what is the precedence of it, how it is done, how it is acted. So I have a detailed notes explaining all of this. So we will go over the detailed notes and see if I miss something to cover, and I'll get back to that. So let's do some hands-on exercise. We'll use that same example of classifying whether the candidate is eligible for hiring or not. We can use that, and we can probably try this UPI conditions as well. Please know that learning this takes less than 10 minutes. But this is going to be super important in your career as a developer. And this is where a lot of bugs or issues come up. And this is where a lot of mistakes happen. So what are some of the best practices to make sure you write conditional statements correctly? Make sure that you do less errors, whether it's in interview or even in the industry when you join. So for this, there is something called test cases, or you can say not test cases, the process is called testing. Okay, testing. So generally, when you become a programmer, right, you start treating your program like a glass jar. So you treat it very like a frugal glass jar where you write the code and you will only give the input for which it will work. Instead of that, you should think it like it is someone else's glass jar and you are supposed to break it. So you have to think with that negative thought, or you have to think that with a attacker or a hacker mindset to see how I can break this code. And don't try to treat your code as a very fragile glass jar. Instead, you wear that hacker mindset and see how you can break it. So for example, the same UPI app, right? UPI app to transfer money from one person to other person, right? So what would be the tests here? The tests would be, -10, then 0, then 1, then 10, then 100,000, right? And then more than 100,000, let's say 110,000 or 100,001, right? So all these values would be input. This is not sufficient. What if somebody enters A there or B there or characters C there? Somebody may intentionally enter, even though it is a number, they'll say enter the number, but they'll put a character there and see what happens. In fact, when most of the software used to run on C, C++, which is called unmanaged code. Unmanaged code. It means there are the variable or the process, the data types that we use and the variables that we use, that process memory was not guarded properly. Lot of the attacking happened by hackers by giving this kind of wrong input, for which the code will crash and they can inject their code into the process. I think all of you must have heard that whenever you get an email with an attachment of an image or a file, do not open it. The reason is that file will have some content for which your client which will open. Let's say PDF you open in PDF reader, image you are loading on some image reader, right? So the attackers used to send those images or files. When you open it, for that input, the process would crash, or they will get an access to the memory outside of the what is legitimate, and they were able to inject the malicious code into the process and take control of your machines. So a lot of the hacking on a legacy systems happens still the same way. If they find a way to crash your code, then they will have a access to your computer. Okay. Now, that is the other reason why you need to be careful. It is not just business logic and money involved. It is also the attackers and the hackers can gain access to your customer's computer if there are these kind of issues. Now, coming to, once you write down all these test cases, then you should think, okay, have I handled it? Have I handled this test case? Have I handled this? Have I handled this? So once you write the code, you make sure you go through these test cases and test whether you have handled it. Now, here comes a very important interview tip. Even in product companies, when you write the code, they look for whether you are able to think all of this cases, test cases, and have you handled all of this in your code? And if you have not handled, as you are testing through that input, are you able to locate where the mistake is and fix it correctly? This forms a very, very important part of the interview process. The grades that we give for your coding skill, if you are poor with testing and fixing and doing all this, then you will not be able to score more than 2.5 or 3 in coding out of 0 to 5. So enumerating these all cases or possibilities and making sure you have handled all this with those conditional statements is an important part for you to score really well in the coding skill and hopefully get an offer. So it may sound very simple, we all are learning trees, dynamic programming and whatnot, and this may look like poor conditional statement, but this can make and break the deal for you in the interview. Now, enumerating the test cases for numbers, you do this. For strings, for string input, for string input, naturally the moment there is a string that is given as an input, naturally you should start with null input, then an empty string with only one character, right? Then string with special characters, then long string, right? String with spaces. So all these, and strings with only numericals in it, only numbers in it. So the moment somebody says string, right, you should not even think, these things should just come like tuck, 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 one after the other. And for numbers, start with like negative number, 0, positive numbers, large number, small number. You don't hesitate in enumerating, because if you are good with this enumeration, then you can go back and see, okay, have I handled null? Have I handled empty string? Have I handled single string with only one character? Have I handled spaces? So for all of this, again, your conditional statements are super important. So with this context, now let's get on a hands-on workshop. So I have generated some notes for you for your reference. So we will share this along with the video. If you are watching it through our website, these all notes and sample code that we write for workshop, they all will be available as an attachment on our website. If you are watching this video on our YouTube, please go to our learning website and you can find it from there. And link to our website, generally you will find it on our YouTube channel or in the video description. So we have really conditional statements let your program make decisions based on certain conditions. That's true. Then one of the analogy that we have given here is for the product companies, what they look for. So they look for coding skills, problem solving skills, CS fundamentals, CGPA and communication skills. So based on this, the hiring decision is being made. And what is the syntax? Okay. In fact, Python has a very simple syntax compared to other languages. All you have to do is write if this is a keyword, small letters, and then you write your conditions here followed by a colon. And the only the important thing here is, in case of languages like say C and Java and C++, you write these blocks in curly braces. Whereas in Python, you have to use indentation or tab. So a tab consists of 5 spaces. I'll show it on the code. So in case of Python, you have that. Like say, I'll say if 10 is greater than 5, then you put a colon here. Then the ID here, actually, if I say enter, it did not go here. It did not start from the beginning. Let me increase the font. It did not go to the beginning. What it did, automatically it came here. The reason here is that here there is a tab, and tab consists of 5 spaces. I'll count this one: 1, 2, 3, 4, 5. So either you can have that or you directly press tab here. Now inside this you can write as many lines as you like, and all of that will be run only if that condition is true. And if that condition is false, then automatically it goes to this line here. I'll say next line. Okay. So is 10 greater than 5? The answer is yes. So what happened? All of that 5 highs we wrote, all of those, or 4 highs that we wrote, all of them got printed, and then next this line got printed. Okay. And let's say we change this to 20. So what would happen? Nothing of this would not execute, and directly it will go to next line. Let's see the output. So only the next line is printed. So please remember, this indentation is important. Now let's do one thing, right? Let's remove the indentation and see what happens. So now what happens? The interpreter will say clearly like this. It will say indentation error, expected an indented block after if statement on line number 1. So the interpreter is able to tell you that you need it. Okay. Now let's say by mistake what I did, I only put that under indentation, and then I didn't put the rest under indentation. So this is what will cause the logical issues. So now interpreter will not know that you wanted to put all of them under if. So it just simply only runs this, and rest all it will run here. So generally, as it's a good coding practice that whenever you write if, you start always on a fresh line, right? And then you generally, write this if else. So let's see the other part, the other part of the conditional statement. So there is something called if else, as we discussed. So in case of Python, you have to write else colon again. So the way to write that would be, you say else colon, and then again you write those statements. So we are in else block, right? So instead of hi, we can also make it, we can also change it to we are in if block. And then at the end here, we can say we are out of if else block, right? So what would happen now? Is 10 greater than 20? Of course not. So the else block will get executed. We are in else block will get executed, and then finally it will say we are out of else. So very simple, multiple lines, you can write it this way. Now let's see what are the next parts. Next is the else if block, and else if is not written complete else if, it is written as ELIF, okay, ELIF, and then you can write conditions like this. So we'll write this with a proper example for our initial example I quoted for hiring decision. We'll write it this way and I'll show it to you. Then the next one is nested if else. The nested if else is like you have an if condition and within that you have another if condition, okay. So let's modify our code. So we are in the if block, and within that again we'll say here if 10 is greater than 7, okay, then you say print we are in nested if. Nested if. So it could be like this, and you can go on like this. There is nothing would stop you like that. You can say, if 10 is less than, see, these conditions does not make sense. You may be asking, okay, it's very obvious, right? 10 is greater than 5. Why are you doing it? Don't worry. It could be like this also. Okay, let me make it even better or more sensible. We can say number one is equal to 10, or we'll say age is equal to 18, okay, and we use this variable everywhere. Okay, so if age is greater than 5, we will say something, age is greater than 7, we'll say something, then we'll say age is greater than, age is greater than 2, then we do something else. So it can go on like this. It can go on like this as long as, you put this indentation and write it this way. And luckily here, this white lines on VS Code tells you, they tell you where, these things are indented correctly. And if you mess up the indentation, see, please observe here, this outer block, you have this 2 indented. And within that if, this condition is there, okay. And because this is starting at this indentation, and then within that you have again this one. Now within this again you have this one. So the way it works, I mean, if I mess this up a little bit here and there also, the interpreter will say that it's not indented. Now, in case of other languages, what used to happen is you could use control key and those braces, and it would tell whether which indentation would match where. But at least in Python, at least you have these white color lines here on the left telling you which block is where. Now, I will debug and show it to you just to visualize how internally it works. There is no watch needed, so I'll just minimize that part. Now you can see what is happening. So the age value is 18. So using the debugger here, I'm using this step into F11. So observe what is happening. So age is 18. Is 18 greater than 5? The answer is yes. So control will jump to line number 5. Then from there it will run, of course, next line 6. Now it goes to 7, and again there is a condition. Is 18 greater than 7? Yes. Answer is true. So it will go to line number 8. It will go to line number 9. Then is 18 greater than 2 again? Yes. Then it goes to line number 11. So you can see that in this case it entered the last part of the block because every condition is true. And then eventually from here it will jump to line number 16 because this all are a part of else block. You could have had a very much same nested if inside this else block as well. Nothing would stop it. Now, most of the business logic would something look like this, and this is where which is error prone and causes a lot of headache for developers. So nested if else. Now this is a very good summary here. So you can see we have listed down all the conditional operators. So one is this double equal to. So double equal to is like you can compare the two values, but make sure their data type is same. You cannot compare an integer with a string. You cannot compare a float with another data type. So the data type of those two have to be same. So here is the table with all these operators. You can see how does the equal to work. So equal to is where you can compare two things. It's just that the data type has to be same. Then you also have operator for not equal to, and many of these conditions can be written in either ways. What is important is the understandability of it. So you should use not equal to only when it is really needed, because you have to inverse the value and compare. Then you have greater than, less than, greater than or equal to, less than or equal to, and then finally comes concatenation of these conditions using AND operator and OR operators. Okay, and then there is something called logical one, which is like not operator and not false. It will invert the value. It will invert the values because sometimes inverting the value makes code more readable and understandable. So that is the reason we have not. Okay, so it will invert that value, and then you can check if that is true, right? Let's say there is a variable where it says person is not eligible for voting because there is certain age restriction. They can vote only if they are 18 years and above, right? So that same condition, you can say if person is not eligible, the eligible is like say true or false, then you can say not eligible, then code will look way more English like, right? So these are practical cases where this get used just to make code more understandable, because you can flip the condition and write it different way as well. Now here is a simple example. So we'll take the same example here and try to write conditions to demonstrate the different inputs. Let me create a separate file and say interview.py. So coding skill 0 to 5, problem solving 0 to 5, CS functional 0 to 5, CGPA is a float, so 0 to 10, then communication is something. So we'll change these values as we run the code. Now we have to make a hiring decision, right? So what is the rule of the organization is what we will see. So rule 1 is candidate passes technical if all core skills are greater than or equal to 4. Candidate should pass technical if or core skills. Core skills means what? Coding skill, problem solving skill, and CS fundamentals. All of this have to be greater than or equal to 4. So how would you write it? So you'll say if, and you generally you write these under parenthesis, or you can avoid it also in Python. Okay, if coding skills is greater than 4 and problem solving is greater than 4 and CS fundamentals is greater than 4, you can observe, right, how we are concatenating this and this and this, and then finally you will say colon, and then you say print the candidate meets the technical level. Okay, and decision is hired. Else print decision is no hire. So now when I run this, the decision is saying no hire because I made a mistake. What is the mistake I made? Like I mentioned many times, developers forget this, which is equal to. So our hiring condition is that if it is 4 and above, we should hire, right? So what I did is I missed this equal to everywhere. So because of that, a hiring decision became a no hire decision, right? So this could be a very good injustice. It is not equal to. Now there is a syntax error. So what is it? It should be greater than or equal to. Greater than or equal to. And then if it is again here greater than or equals to, then greater than or equals to. Okay. So many companies have this rule where they say whatever code you write, it should compile. And I know for a fact that certain companies, they would take the code that you have written and they will just type it. If you have written it on a board or on a paper, they'll just type it. And then they see how many compilation errors it got. And they will mention it in the note saying there were 5 compilation errors for what code this person has written. So why is that? They are very particular because if you have written enough code, then you would know these by your muscle memory. You don't have to memorize them. If you have written enough code, then you would know that this equal to symbol will come after this, right? So this is the mistake. Now let's fix this and run it. Candidate meets the technical level and decision is hired. Okay, this is how the business logics are built, and this is how it is being done. Now let's see the other part of the notes, what it says. CGPA must be greater than 7 and communication should be greater than or equal to 3, right? So let's go here. Now within this, we check if I'm just combining it now. CGPA should be greater than or equal to 7.0, 7.0, and communication should be greater than or equal to 3. And only when these two are done, then you want to hire. Otherwise, you don't want to hire. Okay. So here you can print, let's say, person is good with this, but then academics and communication is weak, right? So here you can explicitly print saying not hiring because of weak communication and academics. You can say that way. And if you are testing this individually, then you can also say it that way, right? So let's say now somebody here, their communication and CGPA is greater than this, right? So it will come to this. Let's say I'll change communication to 2. Then what would happen? Not hiring because weak communication and academics. So it will show this line. It will come to line number 17. Because even though this condition was true, this condition became false. And I'll debug and show so that you can visualize it and see what really happened. So coding skill, all of this is true. So this condition was true and passed. But whereas communication should be greater than 3, greater than or equal to 3, but here communication is 2. So what happened? Automatically the candidate is not getting hired, and we jump to line number 11. Okay. Final hiring decision. So here they have combined everything. You can see that it's combining the first if condition and second. And you can also, by the way, write it this way. Okay, I can show again. I'll just copy paste this code for you to understand. You can write it in this syntax. See, now what is happening here? There is one problem here. The problem is, even if I, let's say, combine these two conditions here, right? Your code width will go outside the viewable window. So there is a thumb rule in industry, which is when you open an IDE, your code should not go outside that window. It is not that you cannot scroll. The code usually should fit in that screen in terms of width and in terms of length, because if you can see the entire code together, then you can spot bugs, spot issues, fix issues, and review it properly. And this rule is super important, because then max you can write is like 20, 25, 30 lines in that screen. Now you cannot say that's what if, sir, I buy a big monitor, big screen. That's not the point here. The point here is, for your employees and colleagues who all have a standard size monitor, whatever it is, the code should be visible in single line. Now the problem with this if statement is, it is going outside the line. So how do you do that? This is the technique. How to do that? Basically, you write it this way. So you write one condition here, you write and move to the next line, and you write and move to the next line. So in industry, generally the conditions are written this way, so that you can see it in that visible window on the editor. And if you write it this way, say even on an exam in paper and all, you can write it that way. But if this is the style you can demonstrate, then it would be nice. Okay, so I'm going to run it again. Hiring decision rejected in both the cases. So here also it's giving that, and here also it's giving that. So this, I think, will give you a good sense of how important it is and how it is done. Now, what is the order or the precedence, what we call? So anything which is under parenthesis takes the higher precedence. You may have a long line, but say you have written some part of that in parenthesis, it takes the higher precedence. And then what takes the next precedence? The next one is these all comparisons, comparison operators, equal to, not equal to, greater than, less than, then less than or equal to, greater than or equal to. All this takes the next precedence. Then not takes the third precedence. Then takes the and or. So this is the order in which it is done. Say for example, here you have coding skill greater than 4 and not communication less than 3, and not communication less than 3, or CGPA greater than 9, eligible for fast track. So what are they trying to say? Coding skill is greater than 4 and communication is see, this is a positive this is a condition like communication is less than 3. Okay, then you may be wondering, how come in hiring decision they are saying communication is less than 3? And this is the example I was giving you earlier. So there is a not applied to it. So if this will be true only if communication is less than 3 and you reverse it, right? So it should not be, communication should not be less than 3 is what you can read it as. So the person, if the communication is greater than 3, communication is greater than 3 and this would be true, right? And then they would make, not would make it false. So for this, don't try to think that how is it applied in real world. I'm just trying to show how this is being calculated. Now let's see, parenthesis is first. So which is first? This will get executed first because the parenthesis is first. Then what will get executed? Then within this parenthesis, of course, these two are there where this get executed first, and then you have this not condition that not get executed. First is this less than, it will compute this whether it is true or false, and then it will reverse that value. So communication, if it is true, it will make it false. If it is false, it will make it true, right? And then it will go for or statement, and within or then it will run this one. So if you want, we can just quickly run it and debug and see it. So you can observe what is happening. Coding skill is 4, communication is 2, then CGPA is 8.2. So what happens here? This condition is not satisfied. Okay, so coding skill 4, this was true, right? So the first condition here, it is like this. So this was true because coding skill is what? Greater than or equal to 4, and not is here. Communication is less than 3, correct? So this is also true. And then you have or where you say CGPA is greater than 8.2, and this is also, the CGPA is 8.2 and actual condition is false. So this is becoming true or false. So CGPA is, it is not greater than, so this also became false. Okay, the if condition would have executed anyway. Now it will not be true for this. So if this becomes true, then it will execute. But here what is happening? Even though it is true, you are negating the value. So what actually it turned out to be? It turned out to be this. It turned out to be true and false or false. So true and false, it became what? True and false became false. In AND condition, if one of them is false, then what will happen? The overall result will become false. So false or false. The final result is false. Since final result is false, this did not get executed. So this is how you understand these logical conditions, and this is the order of precedence through which you can see through it. Okay, so let's go ahead and see the notes. And these are some of the examples I had stated, real world stories of the mistakes. So of course there was, I think this is all public information, nothing very private. It's searched from the internet. There was one NASA Mars orbiter issue in 1999. Then Amazon pricing glitches that they have publicly talked about. Then generally, like I said, 35 to 45% of the business logic involves conditions and crucial for validations, decision trees and algorithms. Now what are the best practices here? Okay, let's look at the best practices, and this is for industry and as well as even your interviews as well. Use clear variable names like say impact score. You don't use IJKLM because already the logical statements are confusing. If you end up using IJKLM, then it will be even more confusing. I'll just show you the reality of it, right? Let's say for coding skill, we were saying I is equal to 4. Okay. And then for problem, we are saying j is equal to 5. And for CS fundamentals, we are saying k is equal to 4. And for CGPA, we are saying x is equal to 8.2. Then we are saying for communication, y is equal to 2. Now, if I ask you write if condition and saying, okay, if candidate has a coding skill of 3 and above and CGPA of more than 6, then select for the interview. So how will you write? So you'll say coding skill of 3 and above. So if I is greater than or equal to 3 and CGPA greater than 6. So CGPA is what? CGPA is x greater than or equal to 6. Then you will say print eligible for interview. Now tell me honestly, you like this or you like this? As you are reading the code, imagine you are reading code written by others. You are fixing that code, or you are fixing bug, or you are enhancing that software. If code that is given to you is like this, now tell me honestly, what would you prefer? Would you prefer this way, code written like this, or would you prefer code written this way? So this is the point that it says that please make sure that your variable names are proper, they have a proper name. Then avoid deep nesting. Avoid deep nesting means the one I showed you. There was a if, then there was a if, then there was a if, there was a if. What happens is it becomes very difficult to test it and debug it. So you avoid deep nesting. Then use else if for multiple branches. Cleaner than nested if. So instead of writing if within if and all, you use else if. That is way more cleaner. Comment complex logic. Make sure you write the comments on top of the blocks, if else blocks. Replace magic numbers with named values. So for thresholds, right now I have used constants here, okay, and those constants are called magic numbers, okay. So that mistake we have done here in this sample code I wrote, okay. So here I have hard coded these values, right? In the entire logic I have hard coded this logic saying 4 4 4 3 3 3. Instead of that, in industry what they do is like this. They will do it right way, this way. CGPA you can say CGPA required is equal to 8.2. Okay. PS level required is equal to 4. Now these are called what? These are called constants. These are constants. So in Python the constant values are written in uppercase. In case of C and other language, there is an explicit keyword called const and you write it that way. And all these constants in other languages, there and all, it goes to data segment. So you have to write it in uppercase like this, and instead of hard coding that as 8 here in the code, you have to use that. So wherever I have this if condition saying CGPA greater than 7.0, I have to use it here like this. Now code looks even more better. Coding skill level is equal to 4. Okay. Now look at this if statement, how beautiful it will get. Coding skill greater than or equal to coding skill level. It almost now sound like English, right? So in the interview, if you are writing code in Python, imagine you declare these constants and use that in your if else. Be it a written test or be it in the interview, it will look nice. Second, you join the industry and you start writing code like this from your day one. All the colleagues and your managers, your bosses, they will all love you for writing a readable code and a professionally written code. Now let's get to the next part. B. Validate input types first. Avoid runtime crashes. So basically whatever is the input, you check that values. So in summary, conditional statements are crucial. They help you make decisions, they help you write business logic, and a single mistake can cost you millions of dollars or embarrassment for your company. So treat them with respect and write them with lot of care. Thank you. Namaste.